For those of you that have used 3D motion tracking solutions such as Syntheyes, which I'm in at the moment, PF-Track, Match Mover, Bijou, etc., you'll be aware that they almost all have these automatic tracking solutions whereby you essentially press the button and it goes ahead and performs the track and solves the camera. However, it's rare for that to give you, in almost every case, to give you an acceptable track. In most cases, it may partially solve the problem. In other cases, it may completely fail. So what we're going to look at in this exercise is how we actually perform what's called a supervised track, where we basically manually place tracking markers and then conform those to the camera. So even if you've used the auto tracking and you feel you've got a reasonable solution, at least in part, you can actually use the same technique that we're going to be going through today to supplement an automatic track to access some areas that you may feel are good sources of tracking but haven't actually been capitalized on by the automatic tracking function. So we're going to start by importing our shot, and we'll take a look at some of the configuration settings. So I've already done this before, so it's generated an IFL file for me, but I'm not going to use that in this particular case. I'll just bring this up into the screencast area. This is the configuration panel. Now these programs, including Syntheyes, are actually very good at looking at the data in the image and actually trying to generate some meaningful metadata from it. You can see in this particular case we've imported an image sequence which comprised of 129 images from 0 to 128. It's placed in there a default frame rate of 24 frames a second. I'm going to leave it at that for now. If you were working to a different frame rate, then you would obviously set that at that point. You can see there that it's looked at the image and it's established. It's had a stab at getting an aspect ratio and a pixel aspect ratio. So it's pretty good in that sense. But you must never rest on your laurels. You must always check these settings to make sure that they conform to your footage and to your project where you intend to place your solve once you've actually achieved it. One thing that you almost always have to deal with is the backplate. Now in this particular case I happen to know that the backplate, this particular footage was shot with a red camera, so I happen to know the backplate for this. Most of the time the backplate is measured in millimeters, so I'm going to flip it over to millimeters. In this particular case, again, it's had a guess at it and it hasn't done bad. The actual setting in this particular case is 24.4. Once we actually set the backplate width, then the backplate height automatically adjusts based on it. And Syntheyes will generate its focal range for the shot based on a combination of this backplate setting and the image and pixel aspect ratio. So once we've actually got those settings in, there are some additional settings in around interlacing and around bit depth and things like that, but we won't be going into those in this particular session. So I'm just going to say OK on this, and you can see that our shot is in, and you can see how quickly the image caches into RAM. Once it's cached, if you take a look at this now, when I play this through, you can see how efficient the software is and how quickly it plays through. It's actually playing through much faster than real time. So it's actually processing. It's going to process the match move data at that kind of speed. We can actually come into the view, and we can actually make some settings here to actually control the speed. So if I set that to normal speed, for example, and we now run it, it will actually run at our 24 frames per second frame rate. But I'm going to set that back to the frame by frame, and we'll stop it for now. So the first principle of tracking, and this applies whether you're performing a feature track, a planar track, or in this case a 3D track, is to actually perform a review of your footage. And this is the reason why these applications usually have some kind of loop-in system like this, so that you can actually be looking at your footage. In fact, I did actually slow this down. I will actually bring it back down to normal speed so we can look at it. We want to be reviewing this footage. We're looking for clues to identify areas which represent sources for good tracks. So we're looking for things like how long a particular or a potential site, if we think about these marker areas as being sites for tracks, then how long those potential sites are in view for, whether they are disturbed by the movement within the action of a shot. For example, some of these areas here are disturbed by the movement of the actor. There, for example, the hand movement going across that one. We've also got some areas where where some markers cross over others, particularly in these areas where we've got our stands that are at different distances away from the camera. We'll talk about that in a few minutes. And also areas where we don't really have any in this particular shot, but areas where the colour values or the luminance significantly changes over the duration of the shot. We've got a few areas, for example, where we've got reflections casting light, and if this is significantly changing, if we were looking to track somewhere in this area and we can see the light changing across that chrome, this would not be a good source, because the actual luminance that's going to be within the feature area of the track itself is changing over time, and that's likely to be disruptive. Okay, so we'll set this back to frame by frame view, and we'll stop at that point. So I guess the idea is to make a mental note of all the areas within the image that represent a potential good site for a track. So let's just do what we were talking about at the beginning and actually perform an auto track on this, just to see what happens. I'm just going to hit that, and you can see there that it computes the blips very quickly and generates a track, and we can see this track now appearing within the space. Now I just want to sort of come into the left view. I'm just going to use the middle mouse button just to pan in on this, and the same with the top view. Yeah, we can see that this is actually an unsuccessful track. So for example, this image, which is against the back wall, we can see it's in this area. It's roughly that distance away from the camera. If we choose another one, maybe for example this one, we can see it's right over here. Now we know these are the same distance away from the camera. They should be adjacent to each other on that plane, but they're not. So this hasn't solved the problem at all. We can also see that the camera position, there's no real fixed sort of height on this. It's really all over the place. So this is a typical example of something that would not address the 3D camera solve that we're looking for. So I'm just going to come into Edit, Undo, and I'm just going to undo a couple of times just to save going back and actually manually unpicking the track, just to get us back to the start position. So we'll start by taking a look now at the process of manual tracking. So I'm actually going to just move over to this corner until my cursor changes and hit that button, just to bring this up into a one camera view. And I'm going to come over into this panel. Oops, accidentally hit the wrong one. This is Syntheyes 2011. Syntheyes 2013 is available now, which doesn't use these icons. It actually uses tabs with text descriptors in, a little bit clearer. But for older Syntheyes versions, it uses this paw, and this brings this panel here. And these are basically the manual tracking tools. So I'm just going to do a couple of these, and then I'm going to flip over to a completed version, and hopefully we'll be able to sort of see some of the principles as I'm going along. So the first thing I'm going to do is I'm going to select this wand button. Once this is selected and active, it means that wherever I click now in the screen, I will generate a tracking marker. So for example, let's just start with this one, nice and bright in the middle, and I just click, and you can see that that marker is set. Just like with many other applications, we can actually change the area of the feature region. We can move it around, and we've obviously got that magnified view in the panel there, so we can get a good lock on there. And we can also change the search area around it. And you can see that these numeric values are changing down here. So we could actually manually set these if we were looking for real precision rather than just eyeballing it. We could set these down here as well. So we've got that in place. If we now sort of went to click anywhere else, we would generate new tracking markers. So I'll just turn that off for now. So at the moment we've placed our marker, but we haven't actually tracked it. So that's what we'll do now. Now we can track forwards or backwards in Syntheyes, but you can see here that we've got a step back one frame, we've got a step forward one frame, we've got a play button, but we haven't actually got a play backwards button, and that's because we control the direction from this button here. So once we set this, it kind of reverses the polarity, so that will now track from the end to the front of the clip. But obviously our CTI at the moment is right at the beginning, so we actually want to track forwards. So once we've actually got that facing in the right direction, then we can hit our play button, and once we hit that, then the track will then work its way through. And you can see there that as it goes through nice and quickly, and we've got a nice lock on that particular element. Once we get to the end, then we need to hit this padlock button, and once we do that, you can see it closes off the tracker. So you see the tracker's still there, but it's now locked off. And the advantage of locking it off there is that we're obviously going to be doing this a lot of times. Every time we do this, it's going to retrack unless we lock it and prevent it from doing so. So just to consolidate, we'll repeat that process. We'll take our wand, we'll make a selection, this area. You can see there that the feature area is quite a bit bigger than that orange marker, so I can scale that in. Scale in the search region if I want as well. Make sure that I'm tracking in the right direction, so my CTI is right at the beginning, so we're tracking forward, so that's correct. And hit the play and watch it go. Once it's finished, lock it down. And that's pretty much all there is to it. It's a fairly repetitive process. Let's look at what happens when we have a slight hiccup. So we'll just choose that area there. Just go in there just to scale up our image. There are our regions, and come back out. So again, we're on the first frame, so we're tracking forward, so we can leave this forward, and let's just track away. Okay, now we saw a slight problem there, and we can see an inference of that on the timeline bar along here. We can see that it's blue, which means it's unaffected. We start to get a little problem there. So what we need to do in these particular cases is we need to get to the last good frame, which is there, and then we use this little button here, which essentially disables any track that's been undertaken either before or after that point, depending on whether you're tracking forwards or backwards. So if I press this now, then what it will do is it'll kill all the tracking data beyond that point. If this was actually going backwards, it would kill all the data this side of that. So obviously I want it to be that way. I'll press the button and you can see that all the data on the bar there has now disappeared. I can now lock that. So this particular tracking solution hasn't given us a full 128, 127 frames, or however long this is. We can see that we've only got it for a finite period of time, just maybe 2/3 of the way into the clip before it disappears. But we do have tracking data now on that particular area of the image. So we'll just do a backward track now, just to see this in action. So I'm moving my CTI over to the end of the frame, and I'm just going to select that one. It's something like centered. Okay, just middle mouse that just to bring it back in and zoom it back in. So this time we're tracking backwards, so we need to reverse the polarity of our track direction bar, and then we hit forward, and we can see there that that's tracking through, and that tracks through the full frame. So once that's done, we can lock that down, and we can see that we're building up a little portfolio of tracking markers. Again, if I can just do one more here, see that this one needs quite a bit of alteration. Essentially, the tracking box remembers the properties from the last one created and applies that. Okay, so we've set one there. This might jump a little bit when it gets towards the edge or the boundary of the frame. So we'll see what happens. Again, we're at the front, so we want to track forwards. So we track forwards. Oh, it's actually done okay for us. So we've got ourselves a track throughout. So let's lock that down. So the principles are that we use the magic wand to create a marker. We can then manually change its size of both of the feature center, the feature region, and the search region. We can do that manually if we want, using the numeric values. Once we've done that, then we establish the direction that we want to track using this icon, and then we track. And if the track is either obscured or goes off screen or something like that before the end, then what we do is we find the last good frame, and then we use this button here to kill all the tracking data either before or after the point, depending on the direction that we were tracking. So what I'm going to do now is I'm actually going to just stop the stop the screen capture, and I'm going to revert to a version that I've already done where we've basically been through the whole shot and tracked it, and then we'll look at what we do in terms of solving the camera. So if you just hold with me for a second. So here we are, and this is a version that I've already worked my way through and completed it. You can see that there's a lot more tracking markers on here now. Just looking in that area at that one actually, just wanted to assess that. It's okay. The center, we can see the center stays locked on there. It's just actually where the track has actually been stopped. So we see the ones that start off screen and then come onto screen over the course. So these are ones that I've actually started here and then tracked backwards until they've disappeared. Okay, now there are some important principles about the tracking which we're going to take a look at, and to do this I'm just going to come into perspective view, and I'm going to just right click and I'm going to say lock to current camera. And what this does essentially is it shows us the track in a slightly different way, or in particular it shows us the markers in a slightly different way. We can see that the shape of the markers have now changed to these upturned triangles, and we can also see that there's a difference in size. Well, actually there isn't a difference in size. The size of these triangles are all the same. What we actually have here is a difference in the distance, the difference between the relative camera and the screen, which is why these, for example, look bigger because they're nearer to the camera. And the important principles here are as such. You essentially want to get a minimum of 6 tracking markers in view on every single frame of the image and at different distances from the camera. That's absolutely critical to achieving the parallax that's necessary. We know that with parallax things that are closer to the camera move quicker relative to things further away from the camera. And parallax is the way that tracking software such as Syntheyes uses itself by triangulation, uses itself to establish the relative distances of things in the foreground to things in the background. So this is why these markers look bigger, because they're actually closer. Okay, so if we go back to the camera and we again just go back to the quad view, we'll just take a look at these views now. We can see that this seems to resemble much more what we would expect. We can see these foreground elements here that are closer to the camera. These would be the stands that are in the very much in the close foreground. These would be the stands that were a little bit set further back, including some of this area on this sort of production furniture on the left hand side there. And then these markers here are the markers on the back wall. So we can see that very clearly. If we come into the left view, again we can see that relationship. We can see that relationship very clearly now. We can see that these are the markers on the back wall. These are the markers that are on the stands in the midground, and these are the ones on the stands in the foreground. And we can also see that there's very much a close relationship there, an adjacence to the floor. Okay, so let's just jump back to perspective view. The final step is to solve the camera. So to do this, we would come back to this view here and we would hit the solve button. Again, this works very quickly, and what this essentially does is this solves the camera. This ensures that the camera is set based on the triangulation that I've just been talking about, and it's set relative to that. So what we actually see then as we move around, if I just, it's a little bit tricky this because of the limited space of the screen capture area. We can see that all these markers are locked on. We can see that they're all following the objects. We can see the markers associated with the furniture that's in the near ground moving a lot quicker relative to things further back, and we can see there that even though we've actually only partially tracked some of these markers, you know, they are actually sort of giving a proper sense and a proper perspective of the 3D scene. So this is essentially the completed track. What we would then do is that we would go into our export protocols, and this would very much depend on what you were doing with this tracking data. If we go into the export, now this is a huge list that goes way beyond the boundaries of the screen capture, but there's actually loads and loads of different settings. The ones that you can just see down at the bottom of the screen capture, for example, the Max script. We've got others elsewhere. I'm just looking to see the Cinema 4D one is actually a tricky one, because this is actually one that for some reason is missing on this particular version, but that would appear as Cinema 4D. On the older versions, you would actually use a Lightwave script, and Cinema 4D would interpret that. You can see the After Effects via Maya there, which is the one that you would use if you were taking the tracking solution straight into the After Effects application. You can see combustion, and there are also some relating to Nuke, which are just off the screen of the capture software. Okay, that's the end of this exercise. I hope you found that useful.